Let's continue section 10.4 with a discussion of arc length. To find the arc length of a polar curve r equals f of theta for a less than or equal to theta less than or equal to b, we regard theta as a parameter and write parametric equations of the curve as follows. X equals r cosine theta, which is the same as f of theta cosine theta. Y equals r sine theta, which is the same as f of theta sine theta. Now dx d theta is found as we did in earlier section, f prime of theta cosine theta minus f of theta sine theta. dy d theta is equal to f prime of theta sine theta plus f of theta cosine theta. We simply use the product rules. Then, if I square both of these quantities and add them together, so in other words, I take dx d theta quantity squared plus dy d theta quantity squared, I'll get f prime of theta quantity squared cosine squared theta minus 2 f prime of theta f of theta sine theta cosine theta plus f of theta quantity squared sine squared theta plus f prime of theta quantity squared sine squared theta plus 2 f prime of theta f of theta sine theta cosine theta plus f of theta quantity squared cosine squared theta. Combining like terms, I will get that the 2 f prime of theta f of theta sine theta cosine theta, those two terms cancel out. Factoring, I get f prime of theta quantity squared times the quantity sine squared theta plus cosine squared theta, end quantity, plus f of theta quantity squared times the quantity sine squared theta plus cosine squared theta. Sine squared theta plus cosine squared theta by Pythagorean identity is equal to 1. So we get f prime of theta quantity squared plus f of theta quantity squared. Or if you prefer the dr d theta notation, we have dr d theta quantity squared plus r squared. Assuming that f prime is continuous, the arc length L is equal to the integral from a to b of the square root of the quantity dx d theta squared plus dy d theta squared and quantity d theta, which we can replace by r squared plus dr d theta quantity squared. So the arc length L is equal to the integral from a to b of the square root of quantity r squared plus dr d theta squared and quantity d theta. So let's look at example 4. Find the length of the cardioid r equals 1 plus sine theta. So our arc length is going to equal the integral from 0 to 2 pi, because we had to go all the way from 0 to 2 pi in terms of theta in order to get a full cardioid. You can look back at example 7 of section 10.3 for a graph of the cardioid. So arc length L is equal to the integral from 0 to 2 pi of the square root of r squared, so we have the quantity 1 plus sine theta quantity squared, plus, we're still under the radical, now we need dr d theta quantity squared. So the derivative of r with respect to theta would be cosine theta. So we'll have cosine theta squared under the root as well, d theta. So now we get the integral from 0 to 2 pi of the square root of 1 plus 2 sine theta plus sine squared theta plus cosine squared theta and root d theta. By Pythagorean identity, this simplifies to 2 plus 2 sine theta under the root d theta. This actually is not easily integrable, so you would have to probably use something like the trapezoid rule or midpoint rule. Or some other computer algebra system. However, if you do one of those, you should get a really nice answer of 8.